This is lessons 12.6 and 12.7, surface area of cylinders, pyramids, and cones. So in this table, we have formulas for lateral area and formulas for surface area for each of the figures that we've discussed. Prisms, cylinders, pyramids, and cones. Prisms we had in section 12.5, and then cylinders come from section 12.6, and pyramids and cones are in section 12.7. So if you look at these formulas, we've already seen and worked with the formulas for a prism. And you'll notice for a cylinder, the formula is the exact same as far as just that basic formula for surface area. And there actually are some similarities here. So if you think about this, the base of a prism has a perimeter of P. The base of a cylinder is a circle, and for perimeter of circle, we use circumference, which is 2 pi r. And you can see that in this figure down here too. This edge right here is the edge that would wrap around this circle, so it would have the same length as the circumference of the circle. So this would be a rectangle with one side that's 2 pi r, and the other side that's h for the height. So that's where that formula comes from. And then the big B for a cylinder is just pi r squared, because it's the area of the base, which is a circle. So the cylinder formula, actually, you can get completely from the prism formula. It's just more specific. Alright, let's look at the pyramid and cone formulas, because there's something unusual that you'll see about these. And that's this little L. Notice there's no height in either of these formulas, or even in the regular surface area formulas. Surely it matters how tall the pyramid or cone is. Well, this L is not length, like we normally think of L. If you look at this pyramid, there's this line drawn along the outside of one of the lateral faces, from the top all the way down to the bottom, but along the side. I could draw the same line. I think this makes it a little bit easier to see. I could draw the same line along this lateral face as well. Think about it as if I wanted to find the area of this triangle, I would need to know the length of the base, and I would need to know the height of the triangle. Since this single triangle, if I cut this out and laid it flat on a piece of paper, this single triangle has nothing to do with the height of the actual pyramid. We're looking for the height along that face itself. So that's what we call the slant height. Because surface area deals with the area of the surfaces, we do want the height of the actual face itself. So these L's for pyramids and for cones refer to the slant height. Okay, we see the same thing for a cone. So the regular height would be from the top straight down to the bottom. The slant height is along the edge. It's the distance from the point at the top to the base. So that's the slant height. Okay, so let's go ahead and take a look at some examples. The first one says to find the lateral area and surface area of each figure. So we need lateral area, and we need surface area. Okay, so we want to make sure we know what figure we're dealing with and that we're using the right formula. So here I see that this is a cylinder. So for a lateral area of a cylinder, I have L equals 2 pi r h. And surface area of a cylinder is S equals L, which we're going to find right here, plus 2 pi r squared. Okay, now take a minute to look at these formulas and make sure that you have all the numbers that you need to plug in. This is radius and height. That's the radius. This is the height. And same thing here, the only thing else that gets plugged in other than what we've gotten for lateral area already is the radius. So we're ready to go ahead and plug in our numbers. Okay, so here we have L equals 2 pi times the radius, which is 3.5, times the height, which is 5. And when we multiply these, make sure you round to the nearest tenth. It actually rounds off to 110 square inches. Okay, let's do the same thing with surface area. So L we know is 110 plus 2 pi times the radius squared. Radius is 3.5. So 3.5 squared. And again, when we compute this, we want to round it to the nearest tenth. We can go ahead and do this separately if we want. 2 pi times 3.5 squared to the nearest tenth is 77. And then when we add these, it's a total of 187. Okay, so there's our lateral area, there's the surface area. Okay, so that is a cylinder. Let's take a look at this next one. So here we see that this is a pyramid, and the base of the pyramid is a square. So we still need lateral area and surface area. Okay, so let's see what formulas we need for a pyramid. We have L equals 1/2 PL, and S equals L plus B. Okay, so again, take a look at the formulas and see what all you need to have. Here I see that I need P, which is the perimeter of the base. So since that requires some extra work, we're going to leave some space over here to find that. For regular surface area, we also need B, the area of the base. So we need to leave some room to calculate that. And don't forget here, this L is the slant height. So that's this length right here, 4.5. Okay, so let's find the perimeter of the base. The base is a square. All four sides are 3 centimeters long. So what's the perimeter of the base? Well, 3 plus 3 plus 3 plus 3, or 4 times 3. Either way, you should get 12 centimeters. Big B, remember, stands for area of the base. We want length times width. So 3 times 3 is 9. Okay, now we can go ahead and substitute into our formulas. And remember again that this is the slant height, so this is L. The perimeter is 12, and L is 4.5. And we multiply these, 1/2 times 12 times 4.5 comes out to 27 square centimeters. Okay, so here we know what L is. L is 27. And B, we calculated as 9. So 27 plus 9, S is equal to 36 square inches. Or centimeters. That's not inches. Oops. Centimeters, not inches. Okay. Anyhow, moving on. On the next page, at the top of the page, we have a cone to find the lateral area and surface area of. So again, we want to write down leave some space to find lateral area. And some place to find surface area. Okay, so write down the formulas for a cone. For lateral area, it's L equals pi r L. And for surface area, we have S equals L plus pi r squared. Okay, so again, look at the formulas, see what we need. We need radius and slant height. There's radius right there. And slant height here, so that's L. Radius and slant height, and here all we need is L, which will come from here, and R to plug in for radius, so we've already got that. So now we're ready to go ahead and start plugging numbers into this formula. So we have L equals pi times the radius, which is 7.7, times L, which is 11.2. Okay, and then pi times 7.7 times 11.2 is approximately 270.9 square inches. Okay, for total surface area, we have S equals L, which is 270.9, plus pi times the radius, which is 7.7 squared. Okay, so 270.9 plus pi times 7.7 squared is 186.3. And then when we add those together, 270.9 plus 186.3, we get 457.2 square inches. Okay, the try it yourself problems are 3 similar figures, so pause the video, work through those. Be very careful again with the pyramid. Remember, you have to find the perimeter of the base and the area of the base in order to use those formulas. So I highly recommend that you do those first. So pause the video, work through those try it yourself problems, and when you're ready to check your answers, press play to continue. Okay, for the first one, the lateral area is 857.7 square feet. And the surface area is 1,550.4 square feet. Okay. For B, the lateral area is 180 square centimeters, and the surface area is 280. Alright, and the last one. For the cone, the lateral area is 122.1 cubic millimeters, and the surface area which is 213.7 square millimeters. Sorry, square, not cube, square. Okay,